Good morning. My name is Shiv C. I am from Narayana University, representing my team Nikhil into national level hackathon, this Martin Hackathon 2025. So our selected problem statement is disaster response for remote areas, and the theme is robotics and drones, and the problem statement category hardware. So I've seen in the many parts of the Wayanad and Kerala and the Karnataka, these parts face severe flood disaster situations in which many of the survivors get stuck in the many major areas. So, in order to detect them and to give them medical supplies, we had created this drone. So, this drone has powered by for emergency response system to deliver the medical supplies and communication devices to the floods, earthquakes, and equip AI for real-time monitoring. So, this innovation, what we had made is for completely focused on disaster response situations and the earthquake and any kind of situation. So, the impact. So, let me talk about the tech stack, what we are going to use and how we are going to do, how we are going to use this drone in those type of missions. So, let's say this is a part of South India. This is South India, and currently we are addressing Odisha. So we can take the Odisha region. So the Odisha region is currently faces with many kinds of floods and earthquakes as seen. So over here, suppose this is debris. So these are the buildings which has been collapsed due to the flood and other earthquakes and other things. So here there is survivor number one. So here is one survivor, here is one survivor, here is one survivor, and here is one survivor. So in the man interruption for NDMA, National Disaster Management Authority, cannot go each and every places to locate the survivors. It is quite impractical to locate those many survivors in those, like suppose let's take of 1,000 square meters. So in 1,000 square meters, so they can locate easily. So what about 10,000 square meters? So it's quite impractical for manual observations which could be made and which could be practically, so we can select those and detect the survivors which is dead, which is alive, which needs immediate emergency response. So for to address this solution, we have addressed this problem and we come up with our drone. So this is the drone which will over here. So this drone over this area autonomously. So the drone will over here autonomously. The drone will be over here. So it will be using lidar sensor and depth camera for measuring the to make a map inside its microprocessor. So let's say SLAM. So we can use SLAM, simultaneous localization and mapping. So this LAM creates a overall replica of this into the processor. So this will autonomously navigate to this drone, which is called as the AI navigation. So it will go over here and it will locate this person. Okay, so this person has been detected over here and he needs immediate response and he needs immediate medical responses. So in order to locate him, so we will be using GPS data. So we will geotag him. Okay, so we will be using the latitude, longitude and altitude. So using a camera. So how it is not detected? So this is a person, okay, and this is our drone. So let's say this is our drone. So this drone will be consisting of two cameras. So one camera is for autonomous navigation and one camera to detect the human. So we'll be training that model, ML model, with lots of these kinds of data sets, so which it can classify the humans which is dead or not dead and which needs the immediate help and response. So it will capture it and the onboard GPS data on the onboard GPS, let's you can take it as Neo M9, which is an RTK based GPS which gives a precise GPS accuracy to the drone. So in that it can take the photo, so it can geotag the location and it can give the GPS data of the person and it can share it to the NDMA, National Disaster Management Authority of India. So it can go over here and it can save the human. So this is what we had proposed, and this is what we are using tech stack. So what is the innovation over here? So this is the impact: 20% faster response in inaccessible regions. Inaccessible regions we can take it as Himachal Pradesh, Odisha, and other major regions in which these kinds of emergency situation happens. And ensure aid during the golden hour. The golden hour, we can see it as after the 24 hours. So suppose we have severe in the Wayanad, we have this severe kind of severe flood. So after 24 hours, we'll be launching our drone, so it can scout and it can detect and it can give the medical aid. And when it goes near to it, and it will launch up the packets autonomously. So this drone will be completely autonomous in every aspect. Either we can take it as the scouting, either we can take it as a detection, either we can take it as a payload dropping mechanism. So everything will be completely autonomous. So we can send hundreds of drones to the north, east, west, and every side of the disaster response, and can make this mission possible and fully autonomously and fully possible in less time. And next, what is this innovation? So end-to-end system, not just monitoring but real supply of delivery and live feedback system. So this will is completely an end-to-end solution. It will go, it will detect, it will give, it will come back. So this is an end-to-end system. AI autonomy. We're using YOLO V8 for the you can use YOLO ULE ones for obstacle detection, deep lab V3 and terrain segmentation, plus DRL, SLAM, adaptive path planning. So these are the algorithms and these are the technologies which we are going to use in our drone, so it can autonomously scout over those regions and can detect those survivors in less number of time and can be provided medical aid as soon as possible. And edge optimized AI including and quantization. Suppose we need to prune, so we'll be using an onboard computer which will be running all these algorithms simultaneously. So it will be working all together. So it will give the best results and in less number of time. And it's completely affordable, scalable, open source stack with low cost hardware. So it's the main thing is B2G, business to the government. So this model on this project is completely proposed to the government, which is completely affordable and scalable in perspective to the government's vision and their So these are technical approaches. So drone launch powered by Pixel and GPS Lipo battery. So drone will launch from one place. So the drone will launch air prescription, YOLO V8 obstacles. So it will run YOLO for obstacle avoidance, deep lab V3 for terrain mapping, and OV for terrain. So to measure these kinds of parameters, we will be using these three major tech stack to implement a complete AI autonomy in our drone. Next, navigation, DRL plus SLAM with fused GPS. So we'll be using DRL and SLAM, so it can go autonomously over those kinds of situations and can detect the people and it can give them medical aid. And next, edge optimization, real-time interference on jet. So what will be the logs? We can take it as telemetry logs, we can take it as GPS logs, or we can take it as the human survived or not. Those logs will be shared in the real time to the ground control station. Next, to optimize it, to make it a next level, a complete prototype like a TRL line structure, so we will be using a mobile app for mission planning, live tracking, and video feed and alerts. So we'll be making a mobile app so in that we can get all the real-time data into our devices. And next, delivery payload drop consumed via weight, sensor, camera, and so it will, the mobile app will make sure that okay, so this person has been located in this spot and he got this medical supply in this number of time. So it will be completely monitored using our mobile app. And during night mode, so this is an optional mode. So if you want a critical response at a time of the night, so we'll be using IR plus thermal vision or any safe operation radar. So this is a completely optional which we had kept for night kind of operation. It is quite impossible for these kinds of drones, but also we had made some innovations so we can use these technologies into our drones, so we can make it as autonomous flying for every kind of situation, whether it will be dark, it will be night, or even flood situations. So this is the feature and viability. This is open source tools. So completely, it will be completely using open source tools like the Pixel, Autopilot, Python, or any kind of open source tools. Affordable hardware with real time. So those hardware which will be implemented in this will be completely affordable and AI navigation and sensor fusion for reliable operations. So we'll be using multi-sensor fusion, so we'll be using many sensors in this, so we can make it reliable and can make it much more affordable and much more precise navigation through those kinds of environments. Next, operational feasibility, design for rugged conditions, low connectivity zones, and minimal human intervention. So completely ruggedly we are making the drone, so it can go to any kind of operation situation which is required. It will go over there, it will detect and will come back. And low connectivity zones where the base station or where the towers and where the Wi-Fi doesn't work. So our drone, we are building in such cases so it can go to any kind of situations which may occur in disaster response. Minimal human intervention. So this, once it's deployed, once the path planning has been deployed, so we do not need any kind of human intervention. So no human is required to operate this completely unmanned aerial system. So no human intervention for any kind of manual operations. Next, finance scalability, cost-effective with scalable deployment, completely cost-effective solution for government, and deployment is completely easy. It's not so very complex as rocket physics or any kind of thing. So we complete simple solution for NDMT and using off-shelf components using open source software. So completely off-shelf using open source, so we will make it as more scalable, more affordable for the any organization which require these kinds of innovation drones. So this is the entire benefits, faster safer delivery, it is responsible 20% of the more index regions, and it's secure organization, efficient use of resources, scalable, cost effective, operates even in low connectivity regions, ensuring the continuous services. This is the impacts and benefits which we have observed right now, and this is the situation. It is in the stage of TRL1, that is technology readiness level 1, in which we have seen the basic principles and technologies which could be used over there. In TRL2, we will be simulating all those open YOLO and OpenCV, all those toolkits in the desktop, and we will be measuring all the efficiency and algorithms which would be required to make this drone autonomously in the upcoming days. And these are the research gaps which we had accessed, and this is the work which we had did. So builds up here maybe disaster studies, but focus on the real-time autonomy. So this is the major gap which we had seen in many of the research papers. So we can make it as complete AI autonomy and implements YOLO V8 semantic segmentation for detecting people, debris and safe zones. So we can completely detect it using the YOLO V8 semantic segmentation. And next, the major thing is not completely a GPS. So it uses less GPS, so it is a complete GPS denied. It is completely a GPS denied UAV, which is for completely based on the AI. It is not only for disaster management. We can use it for defense and any other organization which requires these kinds of services for them. Let's talk about Mahakumbh Mela or any kind of festivals in which we can even we can classify the stampede situations, we can avoid those kinds of situations as well. So it's a multi-purpose UAV, introduces stop, go, logic and adaptive navigation for dynamic disaster management. It's a completely a stop, go, logic which we are using right now in this, provides a practical pipeline for deployable and edge hardware. So this is completely powered by edge hardware, giving the real-time data in less number of time. So this is our innovation, Netra Viman 2, which is focused on these kinds of disaster management response, in which we can protect the lives within less number of time, AI autonomy, multisensor fusion, GPS navigation, and other operational activities which could be done. So we have implemented all those tech in our drone, making and giving us safer and responsible in these kinds of situations. So thank you.